Okay, so now let's define what an increasing and decreasing function is. It's actually easier to look at a function and tell than read the definition, but let's go ahead and talk about the formal definition. A function f is increasing on an interval when, for any two numbers x1 and x2 in the interval, when x2 is greater than x1, that means that f of x2 is greater than f of x1. So, like if you look at this first function down here, you can see that here's an x value 2, and then here's an x value 3, and you can see that obviously f of 3, well, first of all, 3 is greater than 2, and f of 3 is greater than f of 2. And so that's true all the way through here. For if you pick a larger x value, you're going to get a larger y value. So this function is increasing on the interval that I've shown there. Now, a function is decreasing on an interval when, for any two x1 and x2 in the interval, when you pick x2 is greater than x1, f of x2 is smaller than f of x1. So let's take a look here. Here is 2, and you get this y value. But if you choose a larger value, choose a value larger, then notice that f of this value is smaller than f of this value, so therefore this function must be decreasing. Now, if a function is constant, if in an interval, if the functional values are constant all the way through, like this one right here. So that would be constant on the interval that I've got shown there. Now, we've already talked about the definition of a critical number, so let me just mention it real quick. A critical number, you get a critical number when the derivative is 0 at a number or the derivative is undefined at a number. So now, we're going to talk about our first test. We got a few tests in here that we need to talk about. We're going to talk about the test for increasing and decreasing functions. And this is a way to tell where a function is increasing or decreasing. So basically what you're going to do is, if you can find where the derivative is positive, if you can find the intervals where a derivative is positive, then that tells you that the function is increasing on the interval. So if you think about it, that makes sense, because see, this function is increasing. So if you think about this function, when it's increasing, the tangent lines have a positive slope, and the tangent lines represent the derivative, so the derivatives must be positive. So for this function, the derivatives must be positive everywhere on this graph. But for this function here, the one that's decreasing, the tangent lines would have a negative slope, and so that would mean that the derivatives are negative. And of course, for the constant function, the derivatives would have a slope of 0. So anyway, basically, if you can find where the derivative is positive, then you know the function is increasing on the interval. If you can find the interval where the derivative is negative, then that tells you a function is decreasing on that interval. And then if you can find any intervals where the derivative is 0, that tells you the function is constant on the interval. So basically, the guidelines to test for increasing, decreasing is we find the derivative, we locate the critical numbers, and we use these numbers to determine test intervals, and we simply test the sign of the derivative at some arbitrary number in each interval. If the test makes the derivative greater than 0, then the function must be increasing on the interval. If the test number makes the derivative less than 0, then the function must be decreasing on the interval. Now, let's get to an example, and you can see how this works. Okay, so here's a function, 2x cubed minus 9x squared. The derivative is 6x squared minus 18x. Now, if you actually factor this, you can factor a 6x out, and you'll get 6x times x minus 3. And if you set that equal to 0, you'll see that there's two critical numbers, because that's the two values that make the derivative 0. So the critical numbers are 0 and 3. So basically, let's say 0 is right here, and let's say 3 is right here. Okay, so basically that breaks my x-axis up into 3 intervals. All the numbers less than 0, negative infinity to 0, all the numbers between 0 and 3, so 0 to 3, and all the numbers greater than 3, 3 to infinity. Now, I need to pick an arbitrary test number in each of these intervals. And obviously it doesn't matter what you choose, but you want to be smart and not choose any number that's crazy. So the first number that's less than 0 is -1. So I'll choose -1 in this interval. Between 0 and 3, let's just use 1. And then a number greater than 3, let's use 4. Now what I want to do is I want to test the derivative. So I want to find the sign of the derivative. So now, the derivative was 6x squared minus 18x. You can use this or you can use the factored form. But let's plug -1 into the derivative. If I plug -1 into this function, I get 6 times 1 minus 18 times -1. Well, that's going to be 6 plus 18, which is positive. So the derivative is positive at -1. Well, that tells me that the function itself must be increasing over that entire interval, because it can't change over that interval because there weren't any critical numbers in that interval. So the function is increasing on negative infinity to 0. Now let's plug 1 into the derivative. If you plug 1 in, you get 6 minus 18, which is negative. So the derivative is negative on this interval from 0 to 3. So the function must be decreasing on that interval. And then let's plug the number 4 in. If we plug 4 in, we'll get 6 times 16 minus 72. So we'll get, I think, 96 minus 72, which is a positive number. So the derivative at 4 is positive. So the function is increasing on that interval. Okay? So now, if you take a look at this, the function, if you put it all together, the function is increasing on the outer two intervals, negative infinity to 0, union 3 to infinity, and decreasing on the inner interval, 0 to 3. And if you actually look at the graph, you can see that. Notice here, this piece here, the function is increasing, so increasing from negative infinity to 0, and then it's decreasing as x goes from 0 to 3. And then it's increasing again as x goes from 3 to infinity. So there you go. There's how you can determine where a function is increasing or decreasing. Okay, here's another one. This function, the derivative is 3x squared minus 3x. Well, you can just factor the 3x out and get 3x times x minus 1. And if you set that equal to 0, you can get the critical numbers, x equals 0 and x equals 1. And so those are your critical numbers. So basically, we break the x-axis at 0 and 1, and that gives me 3 intervals. All numbers less than 0, negative infinity to 0, numbers between 0 and 1, 0 to 1, and numbers from 1 to infinity. So now pick a test number in each interval. I'm going to choose -1. I pretty much have to choose a fraction in here or a decimal, so I'll choose 1/2, and a number greater than 1, well, 2 will work there. So now if I plug -1 into the derivative, now you can plug it into the factored form if you like. 3 times -1 is negative, -1 minus 1 is negative, so negative times negative is positive, so the derivative at -1 is positive. Now if I plug 1/2 in, 3 times 1/2 is positive, 1/2 minus 1 is negative, a positive times a negative is negative, so the derivative at 1/2 is negative. And then if you plug 2 in, 3 times 2 is positive, 2 minus 1 is positive, positive times positive is positive, so the derivative is positive at 2. So that tells me that from negative infinity to 0, the function is increasing, from 0 to 1, the function is decreasing, and from 1 to infinity, the function is increasing. So we're increasing on these intervals, and we're decreasing on this interval. And if you look at the picture, you can see it again, increasing to 0, and then from 0 to 1 you're decreasing, and then from 1 to infinity you're increasing again. Okay, now Let's take a look at one a little more complicated. If you find the derivative of this function, I'll let you do that. But find the derivative of this function and show that it's actually 4x over 3 times x squared minus 4 to the 1/3. Now, if you set it equal to 0, you're going to get a critical number of 0, because the only way it can be 0 is if 4x is 0. So 0 is a critical number. But there's something new here. This function, if x equals plus or minus 2, the denominator is 0, so that's going to make the derivative undefined. So negative 2 and 2 would make the denominator 0, so those have to be critical numbers too, because they make the derivative undefined. So actually I get 3 critical numbers. I get a critical number at negative 2, I get a critical number at 0, and I get a critical number at positive 2. So now that breaks the x-axis up into 4 intervals: negative infinity to negative 2, negative 2 to 0, 0 to 2, and 2 to infinity. So let's take negative 3 for this test point, negative 1 for this test point, 1 for this test point, and 3 for this test point. Now, let's plug negative 3 into this derivative. Let me clean this up a little bit. Now, this is a little bit trickier, but let's say we plug negative 3 in. Well, the top's going to be negative, right? 4 times negative 3. And the bottom, if I plug negative 3 in here, I get 9 minus 4, which is 5. And the cube root of 5 is positive. And 3 times that's still positive. So I'll get a negative over a positive if I plug negative 3 in. Well, negative divided by positive is negative. So the derivative at negative 3 is negative. Now what about the derivative at negative 1? Well, the derivative at negative 1, the numerator is still going to be negative, 4 times negative 1. But if you plug negative 1 in here, you're going to get 1 minus 3, which is negative, and the cube root of a negative is negative. So the bottom's going to be negative. So you're going to have negative on top, and you're going to have negative on... Sorry, I hit a key there or something. But anyway, so you're going to have negative on top, negative on bottom. So the derivative at negative 1 is going to be positive. Now I'll let you do the derivative at positive 1 and the derivative at positive 3. So just plug 1 in. If you plug 1 in to the derivative, you should find that it's negative at x equal 1. And if you plug 3 in, you should find that it's positive at x equal 3. So based on this results, we know the function is decreasing on this interval and it's decreasing on this interval. So the function is decreasing on those two intervals, and then the function is increasing on negative 2 to 0 and 2 to infinity. So it's increasing on those intervals. And then if you look at the picture, you can actually see that. Notice it's decreasing here. From negative infinity to negative 2, it's decreasing. And then when you go from negative 2 to 0 on the x-axis, it's increasing. Then when you go from 0 to 2, it's decreasing again. And then when you go from 2 to infinity, it's increasing again. And notice that these were critical numbers here because of the sharp corners. That made the derivative undefined at negative 2 and 2. And of course here you got a critical number because you got a horizontal tangent line at that point. Okay, so I'll actually do some more examples on the next video. I actually want to start you out with a trigonometric function on the next video, so we'll get to that when you open the next video.